In this video we're going to look at reflection of waves. So this is actually a very large topic, but we're going to keep it relatively brief because we'll get into more detail with later videos. So first of all, we find it's useful to consider something called wave fronts. So instead of dealing with waves like this all the time, what we might do, that's a side view usually, what we might do is look at them from the top. And if you imagine you're at the beach and you're looking at water waves, you're going to see kind of lines, roughly evenly spaced, and they're traveling in a particular direction. So it's useful to have these wave fronts because you can see exactly what's happening with the direction that they're moving in, and it's helpful in terms of phase as well, because we're going to talk about phase change. And it's also helpful, as we've drawn down here, to give this arrow just to give the direction, because that can help us work out a few things. The direction of wave is always perpendicular to the wave fronts. Now you can draw wave fronts for sound waves, for light waves, for any waves, if it's useful, and it's useful in this case, so we're going to use them. So what we'll do is we'll have a little example, because reflection is quite important, and in fact we'll do a couple of examples. First example, EG1. We'll have a flat boundary, and I'm going to represent it as a boundary by drawing these lines here. Usually you would draw that to indicate a mirror, where this side is the non-reflective side. And we've got our wave, incoming waves. We'll do these in two colours. Incoming waves will be in orange, coming in this direction, directly on, perpendicular to the surface. So here's our incoming waves. I'm going to try and keep them spaced at a similar spacing apart, and so that's going to hit there. When it reflects, because it's hitting straight on, they'll reflect back in exactly the opposite direction. So you will get your waves just passing back in the opposite direction, exactly the same. But this time, because we want to deal with this phase change at a boundary, for a hard boundary the phase will change by 180 degrees. So there's a 180 degree phase change. So if we were being strictly correct in this, we would have the peaks now coming back in this position. It's a little bit strange, because if you're dealing with water waves, that peak, if we're going back to the side view again, that peak is going to seem to travel across. Okay, so they will, but so from that perspective, what you're really going to see is if a peak hits, let's go back to our orange colour, if a peak hits right here, on return, coming back, it's going to become a trough. It's going to become the bottom part. This is much easier seen. So it's kind of irrelevant when you're dealing with the waves incoming and outgoing. It's more relevant at the boundary here. But this is easier to see with a diagram when you're dealing with incident waves that are coming in on a bit of an angle. So let's just continue to shrink as we do, and let's have some waves coming into a boundary. Here's our boundary here this time, and our non-reflective side. So the other side is the reflective side. We're going to have, I'll do it like this. Here's waves coming in, and then boom, they're going to start hitting, and we'll probably get another one in before it turns. And as this hits, you're going to get a small amount of reflection until the whole thing is reflected. I haven't drawn these particularly well, but what this would then look like is that these red lines would be the troughs, and the orange lines are the crests. So where are we? I'm going to have to draw these in between. So the orange lines would be for perhaps a standing wave that's in here, or for an instantaneous look at it. You can see that, maybe you can't see anymore, but you might be able to rewind the video to see how I do it. During the section of contact with the reflective surface, there has been a phase change. So you can see at this point in particular, that maybe we can zoom in. Oh, that's good. You can see that it goes from orange down to red as it's reflecting, or it's red down to orange in actual fact. So and in this one, the orange has hit and reflected as red to show that phase change. Okay, so that's in a diagram. If we're considering a skipping rope, this might be another way to look at it that's a little bit better. So we have a skipping rope, and it's fixed to a heavier line. Let's draw that a little bit thicker, a heavier line. Okay, and now if you flick, so you send a pulse down, oh, I forgot to change the size of it, what you're going to get is, because it's heavier, let's just quickly change my pen thickness, because that's heavier, okay, you'll get a small amount reflected on this side from the pulse, so that shows that phase change, but you'll also get a small amount passing through as well. So all of the energy from the original is preserved, so that's the total energy, and that would be the sum of the energy there and the energy there. Now if we reverse this, so we start with the heavier line, whoops, I thought I was going for the, start with a heavier line, and then that's joined to a lighter line this way, and if we again flick our pulse down in that direction, this time as we have a bit transmitted, quite a lot probably because this is quite a lot, we're going to have a small amount transmitted this way, but the phase this time, the reflected phase, has no change. Okay, so it's in phase, reflected in phase, whereas this one was reflected out of phase down the bottom here. Okay, just important considerations for the details, but you don't actually need to get into that much detail for most situations, especially when we're dealing with curved mirrors a little bit later on.